All right, guys, so since we didn't do everything we were supposed to in class the other day with the sub, we're going to have to take notes on the EM spectrum. So after today in class, you should know that the electromagnetic spectrum is light. And light is something that we cannot see, but it is a wave, and it's actually called a transverse wave. And we are going to talk about all the different types of waves, their characteristics, and how we use them in space. So this is a picture of the electromagnetic spectrum, including all 7 waves: radio, microwaves, infrared, visible, ultralight, X-ray, and gamma. Now, after today, you should know that all waves transfer energy. They do this by disturbing particles, and the particles, as they move and bump into others, carry the energy through different types of media. There are 2 main types of waves: mechanical waves and electromagnetic waves. Mechanical waves are waves that have to have a medium to travel through. For example, air, water, wood, something. Sound waves are mechanical, meaning that if it did not have anything to travel through, like space, for example, it would not be able to move. That is why there's absolutely no sound in space, because there's no air or gases for the particles to be able to vibrate. Electromagnetic waves, however, do not have to have a medium, so therefore they can travel through open space. They can travel through the emptiness of space, like I just said. These waves start with a disturbance, causing all the particles to vibrate and transfer the energy to the next particle. Now, the parts of the waves, we reviewed that earlier. There's the crest, which is the top of the wave, the trough, which is the bottom of the wave, and the amplitude, which is the distance from the midline to the crest or from the midline to the trough. And it tells you how much energy a wave has. The bigger the amplitude, the larger the amount of energy. Now, wavelength is also very important. The wavelength of a wave is measured from crest to crest. It doesn't matter which 2 crests you pick, as long as you pick 2 adjacent crests. The distance between them is called the wavelength. Frequency is the amount of wavelengths that can pass in 1 second. So if you were to count a wave and see that there were 5 crests in a period of 1 second, then its frequency would be 5. And we measure frequency in hertz, so we would say 5 hertz. The higher the frequency, the more energy it has, meaning the shorter the wavelength, the higher the energy. The longer the wavelength, the less the energy. So write that down. So fill in this diagram. You don't need to create it because we already did it in our journal, but you should know that between these 2 crests is the wavelength. The bottom is the trough. The area between the crest and the resting position is amplitude, and the top is the crest. Now, can you find the crest, trough, amplitude, and wavelength between these waves? You should notice that the wavelength is changing. The amplitude is changing. So therefore, you should be able to figure out which one has more energy just by looking at it. So light is a form of energy that travels through an electromagnetic wave, and it does travel in a straight line, which we call a ray. Because it is an electromagnetic wave, it can travel through empty space and matter. And these different wavelengths of the electromagnetic spectrum are used to gain information about distances, movement, and properties of the components of the universe. This is how we know how far galaxies and stars and nebulas are, as we use the electromagnetic spectrum, and we use different parts of them to gather different information. So you use them when you turn on your radio, your cell phone. Those are all radio waves. When you're heating up your food in the microwave, those are microwaves. When you're looking at anything with the human eye, you're seeing visible light. Now, remember, as we said, as the wavelength decreases, meaning as you're moving from the left to the right, and they're getting closer and closer together, that means they have a lot more energy. So radio waves have the least amount of energy because they have the longest wavelength, where gamma rays have the most energy because they have the shortest wavelength. So what do you see when you play with the prism? you can see rainbows. Why do you see rainbows in the sky? Because light is entering through the water droplets, just like when it hits a prism. And when it goes into a different media, it causes it to bend. And when light bends, we call that phenomenon refraction. So the reason why you see a rainbow in the sky is the light is hitting through all the water droplets, bends, and it causes all the colors of visible light to come out. So if you look at this pencil in the water, you can see that it looks like it's bending because the water, as it's hitting the air, which is a certain type of media, now all of a sudden it hits the water, a different type of media, the speed of the wave changes, which causes the light to bend. That is refraction. So what are the colors of the rainbow? Roar G Biv. Remember that? I want you to draw this in your journal. Show the light entering, white light, which is actually all the colors of the rainbow, and then showing it refracting. Red, orange, yellow, green, blue, indigo, violet. Roy, R-O-Y, G, Biv, B-I-V. That will help you remember the order of the colors of the rainbow. So now if you look, which color has the longest wavelength? It's red. Which color has the shortest wavelength is violet. So if I was to ask you which color has the most energy, you should know that it's violet because it has the shortest wavelength. And the color that carries the least amount of energy is red because it has the longest wavelength. So go ahead and pause the video and draw this in your science journal. So we were going to answer these questions. We're going to do a quiz when y'all come in on Monday on your iPad. So make sure if you need to rewind this video at any time, you go back through and draw it. Again, the most important thing to know is the wavelength, the amount of energy, and uses. Have a good weekend.